What if one of our most feared diseases isn't just our own cells going haywire? The source material we're looking at today puts forward a pretty wild theory, that on a molecular level, cancer acts exactly like a parasite. And if it follows the same playbook, well, that might just be its greatest weakness.
Get this, the cure cost $5. That single sentence is right at the heart of the theory we're exploring. It's talking about a simple anti-parasite drug that, in some documented cases, apparently sends stage 4 cancer into complete remission. Now, a claim that bold, it forces us to ask one huge question.
And that question is, how on earth can a drug for parasites also kill cancer? To even begin to understand the answer proposed by our source, we have to go deep inside our own cells and look at a really radical idea of what cancer might actually be. Okay, so let's be super clear on this. The theory isn't saying cancer is a literal worm or some kind of foreign invader. No. What it's arguing is that cancer cells have basically hijacked the exact same ancient survival machinery that parasites have been using for like billions of years. They steal our resources, they spread, it's all from a very, very similar playbook.
And you know, this isn't just some abstract biological puzzle. To give this some real-world urgency, the source points to a pretty startling statistic. Cancer in young people has reportedly jumped by 79% in the last 30 years. That's a huge number, and it makes understanding every single potential angle on this disease more critical than ever. All right, to really wrap our heads around this parasite theory, we need to start with the basics, how our cells make energy. Because according to the source, there's a fundamental difference here that separates a healthy cell from a cancerous one.
So inside almost every single healthy cell in your body, you've got these amazing little power plants called mitochondria. The best way to think of them is like these super efficient engines. For every 1 unit of sugar or glucose they take in, they churn out a whopping 36 units of energy. Super efficient.
Now, check out this contrast. A healthy cell gets 36 units of energy. A cancer cell? The source says it only gets 2. Just 2. I mean, that's an incredible drop-off. It's wildly inefficient. So the big question is, why on earth would it do that?
Well, this goes back almost a century to a Nobel laureate named Otto Warburg. According to the source, he discovered that when a cell's mitochondria get damaged, by toxins or radiation, things like that, the cell flips a switch. It basically falls back on this ancient, primitive backup system called glycolysis. And this system is old. We're talking bacteria and fungi old. And it's incredibly inefficient. And this actually connects to something you might have heard of, a PET scan. Ever wonder how that works? Well, they inject you with a type of radioactive sugar. And guess what lights up like a Christmas tree? The cancer cells. Because they're running on that terrible, inefficient system, they are absolutely starving for glucose. They just gobble it up. Okay, so we've got the whole energy thing down. Now we get to the real heart of the theory. 3 key survival systems that the source claims are almost identical between cancer and parasites. So here they are. Think of these as the 3 pillars of their shared survival strategy. First, they need an internal scaffold for structure. Second, a way to hide from our immune system. And third, they run on that same inefficient fuel. Let's break each one down. First up, that internal scaffolding. See, both cancer cells and parasites are all about one thing: non-stop rapid division. The source uses the example of a tapeworm, which can pump out 50,000 eggs in a single day. To pull that off, they both rely on this special internal skeleton. Think of it like tiny tubes that give them structure for that relentless multiplication. Okay, the second parallel is really cool. It's basically an invisibility cloak. Normally, if a cell in your body gets damaged, it has a self-destruct button it pushes for the good of the team. But cancer and parasites, they've learned a trick. They wear this little molecular badge that basically says, "Nope, don't kill me," and it completely fools your immune system. And number 3 brings us right back to where we started, the fuel. Both cancer and parasites run on that exact same primitive, sugar-guzzling energy system, glycolysis. It's like they're both powered by the same ancient, clunky engine. And, importantly, that could be a major weak spot. So, if they share the same playbook, if they have the same weaknesses, it leads to a really obvious question, right? Can you defeat them with the same weapon? The source argues, yeah, you can, by targeting these 3 systems directly. And this is how it supposedly works. The theory is that these common anti-parasite drugs, the kind that led to that whole $5 cure idea, go after all 3 of these weak points. First, they supposedly grab onto and break down that internal skeleton. Second, they rip off that "don't kill me" badge so the immune system can finally see what's going on. And third, they block that energy pathway, basically cutting off the fuel supply.
All right, this all leads to the big, obvious question, right? If this is even remotely plausible, why isn't it front-page news? Why haven't we all heard about it? Why isn't it being tested everywhere?
While the source offers a few explanations, and honestly, they mostly come down to money. For starters, these are old generic drugs. Their patents expired a long time ago, so there's just no financial incentive for a company to spend millions on a huge clinical trial for a drug that costs a few bucks. Because of that, the research that is happening tends to come from small university labs, not the big pharmaceutical companies. And finally, the people who believe in this theory point to a growing number of published case studies as their proof.
I mean, look at this one mouse study the source mentions. The results were just night and day. The mice that got the drug, 100% survival rate. The mice that didn't, 0%. It's that kind of really dramatic lab data that gets people's attention.
Now, it's really important to say the source doesn't frame this as some kind of magic pill. Not at all. It really emphasizes that our own immune system, our killer T cells, is the most powerful weapon we've got. The whole argument is that these drugs are just a tool to help your immune system do its job better. And that should be supported by things like diet, lifestyle changes, all of it.
And so we're left with this one last, really fascinating question. The source material is basically asking us to wonder, could the key to fighting one of our most complex, modern diseases be hiding in plain sight? Hidden inside the ancient survival codes shared by some of the simplest life on our planet?